Hello students, today we will continue analytic function. Let us consider one example. Find analytic function f of z which is u plus iv where u is equal to r cube cos 3 theta plus r sin theta. Now we know that CR equations in polar form are da by u upon da by r is 1 upon r da by v by da by theta and da by v upon da by r is minus 1 upon r da by u upon da by theta. Now since u is given, da by u upon da by r equal to 3r square cos 3 theta plus sin theta and da by u upon da by theta will be minus 3r cube sin 3 theta plus r cos theta. Now from CR equations we can say da by v by da by theta is r times da by u upon da by r. So it becomes 3r cube cos 3 theta plus r sin theta. Now integrating this with respect to theta, treating r as a constant, we get v is equal to 3r cube sin 3 theta upon 3 minus r cos theta plus f of r. Now v is equal to r cube sin 3 theta minus r cos theta plus f of r. So da by v by da by r now we can write as 3r square sin 3 theta minus cos theta plus f dash r. Here theta will be constant. But da by v upon da by r is minus 1 upon r da by u by da by theta because of CR equation. So da by v upon da by r becomes 3r square sin 3 theta minus cos theta. Now comparing these two sides, we can easily say that f dash r will be 0. So f of r is constant. So v becomes r cube sin 3 theta minus r cos theta plus c. Now we know that f of z is u plus iv, put values of u and v. Now if we write in this way, r cube cos 3 theta plus I sin 3 theta plus r common into bracket sin theta minus I cos theta plus I into c. Then if we use exponential form of complex number, z is r e raised to I theta, then this is how we can write it. So finally f of z will be z cube minus iz plus c1, which is required solution in terms of z. Now next example, determine value of k such that the function f of z equal to e raised to x cos y plus I e raised to x sin ky is analytic. Now here if we compare the given function with u plus iv, then u is e raised to x cos y and v is e raised to x sin ky. Now if we differentiate u partially with respect to x, then da by u by da by x is here e raised to x cos y and da by u upon da by y will be minus e raised to x sin y. Similarly, if we differentiate v partially with x and partially with y, then da by v by da by x is e raised to x sin ky and da by v upon da by y is k e raised to x cos ky. Now by CR equations we know ux is vy and uy is minus vx, where x and y suffix denotes partial derivatives. Now if we equate these two, from the derivatives we get e raised to x cos y is k e raised to x cos ky and minus e raised to x sin y is minus e raised to x sin ky. So easily one can observe that k must be 1. So k equal to 1 is the required value. So this is how we can find the unknown when the given function is given as it is analytic function. We can use CR equations. Now remark, very important remark is analytic function f of z with constant modulus is always constant. Next, consider the example. show that analytic function f of z with constant amplitude is constant. Let us consider f of z is u plus iv. Amplitude f of z will be by definition tan inverse v by u equal to c, which is constant, or v by u is tan c equal to k. Now let it be equation number 1. Now differentiating 1 partially with x, we get by the usual way of derivative u dabba v by dabba x minus v dabba u by dabba x upon u square equal to derivative of constant will be 0. So we can say u dabba v by dabba x minus v dabba u by dabba x is equal to 0. Suppose it is equation number 2. Now differentiating 1 partially with respect to y, we get u dabba v by dabba y minus v dabba u upon dabba y is 0. Now, by CR equations, we can say, we know that ux is Vy and Uy is minus Vx. So, in place of dabba V by dabba Y, we can substitute dabba U upon dabba X, and in place of dabba U upon dabba Y, we can put minus dabba V by dabba X. So, this is what we get after putting CR equations. Now, solving the equations 2 and 3. Solving equations 2 and 3, we get, that is multiplying 2 by v and 3 by u, and subtraction will give us that u square plus v square dabba u by dabba x is 0. But since f of z is u plus iv, u is real part and imaginary part, we can say definitely that u square plus v square should not be 0. So we can say dabba u upon dabba x must be 0. And in same way we can say dabba v upon dabba x is 0. Now by CR equations, we know that ux is Vy and Uy is minus Vx. So, dabba V by dabba Y will be 0 and dabba U upon dabba Y will be 0. Now, integrating dabba U by dabba X equal to 0 with respect to X, treating Y as a constant, U is equal to f of Y. Differentiating differentiating we get dabba u upon dabba y is f dash y, which is equal to 0. Therefore f of y is c, or we can say u is constant. And again similarly we can say v is constant, therefore f of z is u plus iv is again constant. So this is how we have proved that analytic function f of z with constant amplitude is constant. Thank you.